Hello everyone, it's the Motorcycle Muse here, and I just want to do a quick video to show you how the starter motor, which is this component here, I want to show you how it works. So I'm going to start off by showing you how the actual starter motor gets the motorcycle engine running, and then I'm going to take the starter motor off the engine and I'm going to take it apart and explain how it actually works, how the internals of the starter motor work. So what the starter motor does is it actually acts on the crankshaft in the engine to get it turning. Okay, so the crankshaft is the shaft that runs through the center of the motorcycle. So it starts from here and it's just one long metal bar that runs the whole way through the engine, and the crankshaft is actually connected to the piston. Okay, so this is the crankshaft here. Here's the end of the crankshaft, and as you can see, the piston, normally when the engine is running, the piston is going up and down and it is actually driving the crankshaft. So it is causing the crankshaft to rotate. So that is when the engine is actually running. Now when the engine is not running, we need to get this crankshaft turning. Okay? So to do that, the starter motor acts on that crankshaft through a number of reduction gears. So here you can see I have all the covers removed from this particular engine. I have the cylinder removed so you can see the piston, but I've left in the little reduction gears. So the starter motor has a little shaft coming out, or a geared shaft coming out from it, and it acts on a number of reduction gears here. So I just have them inserted in place, but I can take them out quite easily. So essentially, as this output shaft from the starter motor is returning, it acts on these gears and causes them to rotate. And this series of gears, if I just take them off here, so this is the first one. It's obviously quite different depending on which motorcycle you look at, but there's generally going to be a reduction gear. So here's the first reduction gear. So the output shaft from the starter motor acts on this gear, which causes this reduction gear here to rotate, and this rotating gear acts on another reduction gear here, so it causes this gear here to rotate, and this gear causes another gear here. As you can see, as I rotate it, it causes this gear here to act on the driven gear, or the starter clutch driven gear. Okay, so when that starter motor is activated, has power going to it, and it's running, it drives these gears which act on this driven gear, this starter clutch driven gear. And as you can see, it's causing the crankshaft to rotate, and it's causing the piston to go up and down. Okay? And that's essentially how the starter motor starts the engine. So the starter motor itself receives power when we press on the starter button. Generally, when that button is not being pressed, the circuit that supplies power from the battery to the starter motor is broken. The starter motor is not turning. Now, when I turn on the ignition, I am allowing power to reach this circuit for the starter motor as soon as I press this starter button. So I press the starter button now, and it's going to it's going to supply power to the starter motor, and you're going to hear the starter motor cranking over. So what you'll notice there is that I only pressed this button in for a couple of seconds. So I only pressed it in for about 2 seconds and then released it. So the starter motor only turns for maybe 2-3 seconds to get the engine cranking over, and once the engine is cranked or started running on its own steam, you take your finger off the button and that stops the starter motor from running. So I've got my starter motor hooked up to the positive terminal of a battery, and I have the jump lead connected to the negative terminal of the battery as well. So I'm just going to jump the starter motor, and we should be able to see the piston moving up and down. So don't worry about the sparks you're going to see. I just want to demonstrate how the starter motor turns over the engine when it's off. Okay, so I've taken the starter motor off the engine, and I'm just going to open it up so that we can take a look inside and explain how it works. The first thing to note though is that the lead that leads onto the starter motor, this is connected directly, in this case it's connected directly to the positive terminal of the battery. So the other thing to note on the outside here is that we have some little alignment markers here. So the starter motor is composed, I suppose, of 3 components on the outside. There is the front cover, we have the rear cover, and then we have the center body, and they all have to be lined up. So there's little markings on the 3 bodies, or the 3 pieces, 3 parts of the casing, to indicate how they should be lined up. So when you're putting it back together, they have to be aligned. Now, all that's holding these 3 casings together is 2 long screws. So I'm just going to undo these two screws. So it's just a Phillips head screwdriver. I've already loosened them, but they will be torqued down to it quite tightly. So you need to be careful that you're using a good quality Phillips head screwdriver when you're undoing these bolts or these screws, these long screws, because otherwise you're going to strip the heads on your screws and they're not going to be readily available. So you want to keep these screws in good condition. Because the starter motor on your motorcycle, if it starts acting up, or if it starts to not work, it can actually be repaired in a lot of cases. So those screws are important. Okay, so the screws are off, so now we can just remove the rear cover. Okay, so with the rear cover off, there's not much to show you really. All we can see here is the end of the armature. There's also a little shim, which is the little washer type. Looks like a little washer, but that's a shim. So I'll put that to the side. And in the front, we can remove our front cover. Okay, and that just slides off like so. Again, the front cover has another shim. This time it's just a larger shim. So we'll keep that, put that there to the side so it mustn't get lost. Okay, so it's all very easy to get at. So straight away we can see now underneath the front cover we have a number of brushes. So the brushes are just these little components here. There's 4 of them, 4 brushes. The brushes are mounted on springs. So let me just try and do a close-up here of this so you can see it all clearly. Okay. So again, here are our 4 springs, or sorry, our 4 brushes. And again, they are spring mounted, so there's 1, 2, 3, 4 springs. And the role of the springs is to ensure that the brushes are being pushed inwards. So they're always being pushed in towards the center by the springs. And they're being pushed in towards the center to ensure that they make contact with this commutator, which is mounted on the armature. So the armature runs the whole way through the center of the starter motor. So here's the back end of it, and this armature runs the whole way through to the output shaft. Okay, and this is the output shaft, which again is connected in with the gears, the reduction gears that drive the crankshaft and turn the engine over to get it started. Now we also have some seals. There are seals here, and then we have a seal here, and that's to keep rain, dirt, dust, oil, everything out of the starter motor. So the armature that runs through the body of the starter motor is actually a large electromagnet. So what is an electromagnet? An electromagnet is an electrical component which becomes a magnet when current flows through it. So an electromagnet is a temporary magnet. It's only magnetic when there's current flowing through it. Now, just inside the casing of the starter motor is actually another magnet. This time it's a permanent magnet. So a permanent magnet is a magnet that remains magnetic all the time. It doesn't need current flowing through it, it doesn't need anything. It's just always magnetic. An example of a permanent magnet would be the magnet that sticks to your fridge, a fridge magnet. That is a permanent magnet. No matter what you do with it, it's always magnetic. Well, it's the same with the magnet that's just inside, and it's basically the same shape as this outer casing, only smaller, and it fits inside. Okay, so basically we have the permanent magnet inside. So the electromagnet fits inside the permanent magnet. So you can see it here. So this is the electromagnet, or the armature commutator. It's called the commutator, or the armature commutator, and it's essentially the electromagnet. And this armature sits inside the permanent magnet. Okay, so they're quite close to each other. And essentially, when current is applied to the starter motor, current flows through the armature and it becomes magnified, or magnetized, sorry. So we have 2 magnets, and magnets, the 2 magnets are actually exerting a force on each other. But because this armature is stuck permanently inside the starter motor, it has nowhere to go. And what that force results is, the magnetic force from being exerted on the armature by the permanent magnet causes the armature to start rotating. Now, as soon as current to the starter motor is stopped, the magnetic field the magnetic field in the armature collapses and we have no more magnet, and as a result there is no more force on the armature and it stops rotating. So that's essentially how the starter motor works. Now this armature, I can actually move it out. I can take it out. I'm going to take it out in a second, but I just want to leave it in so that I can show you how the current is received into the starter motor, or into the armature. So there's little commutators. Okay, so these little metal plates. So hopefully you can see them there. There's little copper metal plates the whole way around this armature, and they're the commutators. Okay, so they're the little electrical conductors. Now inside the, you can see it better here, the armature is made up of copper wire windings, and it's the wound up copper wires that current flowing through the wound up coils of wire induces the magnetic field. Okay, so that's why you're seeing all these wound up copper wires. Wound up copper wires, or current flowing through wound up copper wires, induces a magnetic field. Now current flows into these wires in the armature through these little electrical plates, or these little copper plates called the commutators. Okay, and the commutators are connected with these little brushes. Okay, so the brushes are actually little blocks of carbon. Okay, now there's 4 brushes. 2 of the brushes have copper wire connected to them. So this one here, as you can see, there's some copper wire, a large lump of copper wire connected to this brush, and to this brush we have a large copper wire. So these are these 2 brushes are the positive brushes, and the other 2 brushes are the negative brushes. Okay, so this one and this one. So these 2 brushes are going to be connected to the casing, the ones with material covering. It's just a material covering essentially, but they have wire inside them underneath the material covering. So these 2 brushes are going to be connected to the casing. Now the casing, just think about our casing. When it's connected up to the motorcycle, the starter motor is when it's connected up to the motorcycle. The starter motor is actually screwed on by 2 bolts. It's bolted on to the engine, the block of the engine. And that is significant because the engine block is grounded to the negative terminal of the battery. So the negative terminal of the battery is connected to the engine block. The engine block is connected to the starter motor. The starter motor is connected to the engine block, so current can flow from the negative terminal of the battery to the starter motor casing. And then these negative brushes, these 2 negative brushes, are connected to the casing. So when I take this off, you'll see that the 2 negative brushes are connected to the casing. Now the 2 positive brushes are going to be connected to this positive terminal here, which feeds in separately. Okay, so this positive terminal is connected to the casing, but it is insulated from the casing, and it allows there is positive leads to these positive brushes. So that's essentially what the brushes are for. They are spring mounted to supply power. So current basically flows in through the negative. The electrons flow through the casing, in through the negative brush. They're going through into the commutator. Okay. So every time it turns, it's touching a different commutator. So the commutators are just different plates. They're separated plates. Okay, they're all separated, And each commutator is connected to a winding of wire. And those winding, as the current is flowing around those windings of wire, it creates a magnetic field before it continues to flow through to the positive terminal, the positive brush, and down this lead here. So that is the flow of the electrons or the current through the starter motor. So I'll go through that again. The current flows in through the casing, or the electrons flow in through the casing, which make up the current. They come through down this negative brush. They come to this commutator here, this little copper plate, which is connected to the copper wire windings, creates the magnetic field in the electromagnet, and then comes back up through the two positive brushes, again through the commutator, the copper commutator, which is connected to this brush at this particular time, and then out through the positive terminal which leads from the starter motor. And that essentially is how the starter motor works. So let's remove the armature. Now, when I slide out the armature, I move it out that way. The spring mounted brushes are going to click inwards. That's not going to be a big problem. But when you want to put it back in, you have to pull the brushes, the spring mounted brushes, you have to force them all back outwards to allow the armature to come back in. So that's why I didn't want to take it out initially. Now the one thing to probably note here is that because the brushes are in contact with the metal commutators, or the metal plates, there is going to be wear over time, and your brushes are going to wear. And when the brushes wear, they're not going to be as good electrical contacts, and you may need to replace the brushes. So let me just go ahead and just push it out. So hopefully you can see that clearly enough. So just keep an eye on the brushes. So there you go, they just pop in. Okay, and if I come around here, now the permanent magnet is trying to actually force the armature back in. So here's our armature. Hopefully this is all clear. So there's our armature. Here is our commutators, the little electrical contacts that the brushes touch off. And you can see that the commutators are connected up by little copper wires to the wire windings to the copper wire, which is then wound up. And as you can see, it's all wound up. And the whole thing, all the wires, apart from the commutators, all the wiring is all coated in an insulator here. So it's just one big lump. I can't disconnect anything else here really. I can possibly take off this little spring clip here. I might be able to move this off this whole copper wire winding unit off this armature, possibly get a new one, but there's no need to do that. I don't need to disconnect this to show you. Essentially, that is it. That is your armature. Inside here, we can see the permanent magnets. So these are just the permanent magnets there. Hopefully it's clear enough. Hopefully that's a little bit clearer. Okay. And then we have our positive brushes, which are these two, which are on the copper wire.